Good day. Today we're looking at vectors. A vector v in the plane or in the space is represented by an arrow, and it is determined by its length and its direction. Two arrows will represent the same vector if and only if they have the same length and they are parallel. Vectors are used for representing entities that describe magnitude and direction. Physics uses vectors a lot. Now here's my example to you. If you're pushing a box, and whenever you're pushing eastward with a force of 4 newtons. You're pushing northward with a force of 3 newtons. In what direction and with what force or magnitude will this box go? Now we'll answer that here in a minute. Let me show you how to do these problems. If given two endpoints, x1 and y1, x2, y2, the vector is represented by the distance between your x and y values. The magnitude of a vector is the square root of your x value squared plus your y value squared, and your direction is the arctangent of your y value over your x value. For 1 through 3, find the component form and the magnitude of AB given the initial and terminal points. So I'm going to do number 2. I'll let you try 1 and 3. So for AB, I'm going to take my x2 value 5 minus 4 and negative 5 minus negative 2. This is going to give me 1 and negative 3, because that's negative 5 plus 2. There is my vector. My magnitude is going to be the square root of my x term squared plus my y term squared. This is the square root of 10. Pause the video, tries 1 and 3. You should get negative 3 and 1 for the vector with a magnitude of the square root of 10 for 1. For number 3, you should get 11 and 5 for my vector. Magnitude of square root 146. Adding vectors and vector components. I want you to notice in this diagram, what they have done is they took the B vector here, and they simply pulled it up to the terminal point of the A vector. So the initial and the terminal points meet. The new terminal point formed is what gives me, let me turn it to the red, is what gives me my combined vector. That's graphically. You can do multiplication by scalars. You can add, subtract. I'm going to show you how to do 2 of these problems and let you try the other 2. I'll do numbers 4 and 5. You do 6 and 7. For number 4, this is going to be 3 times my v vector is 2 for the x, and 3 times the y value is negative 1. This is 6, negative 3 as my vector. W minus 2v. Okay, my w's x-coordinate is negative 3. I am subtracting 2 times the v-coordinate, 2. This is 5 subtracting 2 times negative 1 for the y. When you do this, you're going to get -3 minus 4, -7, and 5 plus 2, +7. Pause the videos, try numbers 6 and 7, and you're going to get -1, 11, and -21, 28. Now let's answer that initial problem about pushing the box. Now to do this graphically, you could move the either vector, your choice, and get the line of this. But I'm combining the 3 to the northward component, 4 to the eastward component. So here is the resulting right triangle that allows me to find my magnitude and my direction. The x value is 4, my y value is 3. The direction angle is going to be here, because that's how I'm pushing the box. So, if I'm looking for the force, the magnitude, I'm finding the square root of 3 squared plus 4 squared. 9 plus 16, 25, square root 25 is 5. If I'm looking for this direction, I need to find arc tangent opposite over adjacent. Now keep in mind this is in degrees. So I'm going to show you in Desmos so that you can do it on your work for today. Keep in mind we're talking about degrees. Arc tangent, 3/4. I'm pushing at a degree of approximately 64 degrees. Sorry, I'm used to being in radian. I'm used to being in agreement from the testing version, not radians. I looked back and saw the decimal, so I knew it was wrong. Approximately 36.9 degrees. Make sure you are in degree mode. I like using the testing version of Desmos. That's what you get to use in college. But if you're not using it, and if you are, it's still a good idea to check if you're in degree mode. All right, that is all that I have for you today. Have a great rest of your day.